As with most things that are new and strange in our lives, Hollywood has made us rather fearful of artificial intelligence, or AI. How many movies have you seen where killer robots or supercomputers use their advanced capabilities to enslave mankind? But as we shall see, AI and its dance partner robotics might not be the nemesis we should fear. At least, not if we get them right. Problems once solved only by humans are now routinely managed by AI, and the transition seems to have been seamless. As with human intelligence, the essential questions about AI are where it comes from and the uses it is put to. Chances are you have already made contact with an artificial intelligence sometime today and didn't even know it. Used a mobile phone? Surfed the net or used a search bot, social media app or email? Watched streaming TV, bought or sold shares? Used an elevator? Worked in a smart building? Caught public transport or been guided by GPS maps? Well then, an AI was almost certainly involved.
Quite obvious, we think our intelligence comes from the brain, so why don't we make an artificial brain? People have studied how the brain works, and actually we still don't completely understand how the brain works, but we've got a fairly good idea now. And neurons are one of the main things in our brain, so the neural network is the computer equivalent of how the brain works. In technical terms, you have some inputs and you have some outputs, and the neurons are the function in the middle. They might add the numbers, for example, if it was a really simple system, or they might do something more complicated. With that kind of neural network, you can only solve relatively simple problems. So early on, that technology was very exciting, but then it didn't really work for more complicated things like, for example, images. Then the neural network community came up with more advanced designs, and they call them deep learning designs. And it's a little bit like a neural network with more inputs and more layers. So deep learning to me is more complicated neural networks in a way. And it works really well actually, because it can now process much larger quantities of data and solve much more difficult problems.
Put very simply, machine learning is the science of making computers learn from the data they analyze, identify patterns, and make decisions while keeping human hands-on intervention to a minimum.
So I think AI is used a lot these days already, and sometimes it's hidden, so you don't notice that. I mean, the classic examples where you might know is in your washing machine. You know, now the washing machine uses fuzzy logic, which is one version of AI. Maybe you heard of that. That was something more people started to get aware of. But I think AI is actually used a lot. I mean, for example, did you come by a tram this morning? Well, the timetable for the tram was designed by AI, for example. So you wouldn't know that, but that's how it's done. Already AI is used a lot for medical data to help with things. And talking to your doctor, you might not be aware of that, but already they're benefiting from this. So it's used a lot, but it's still in the early stages, and I think the use will increase further and further. Currently, we get approached by a lot of industries and companies who haven't maybe used AI so much, and they suddenly realize the potential. I think the first step is to collect the data for them, and they're kind of reaching that point now. And now they're like, well, what are we going to do with all this data? And then comes the AI step.
So AI is big business for big business, which now routinely uses machine learning as the driving force for change and improvement in financial services, healthcare, online retail, tax accounting, and the list is growing fast. Investment in AI is skyrocketing as it turns itself into an essential tool for data-driven decision-making. How far can machine learning go? And should we be figuring out a system of checks and balances to control its applications to human life?
If you like, machine learning algorithms are always improving. There's a lot of research right now going on to doing machine learning more effectively, more efficiently. And one thing you learn about research is whatever the current technique is now, we can always improve on it.
And so machine learning would be the actual algorithm that would eventually result in artificial intelligence, but it's only part of it. So, for example, machine learning doesn't include the preparation of the data, it doesn't include the modeling of the problem, and it doesn't really include what happens later on, which is the translation of the computer solution to the real solution, which may also involve some steps.
The early steps in machine learning involved games. IBM's Deep Blue computer beat Russian chess master Garry Kasparov. Then the famous Watson supercomputer won the game show Jeopardy in the US. More recently, Google's AlphaGo program beat one of the world's best players of the game Go, Lee Sedol, by 4 games to 1. Shortly after, the new AlphaZero AI beat world champion programs in chess, the Japanese game of shogi, and Go with only 1 day's training. This is called deep learning.
What this particular set of machine learning algorithms was able to do was play enough games against itself to learn not just the rules, but learn the best strategies. So the deep learning part of it refers to a particular neural network or a particular machine learning algorithm set up in a particular way and played itself millions and millions and millions of times.
So as we've been studying this for some time, I mean, one of the things about intelligence is creativity. For me, at least, that's very important. And that's one thing we're struggling with a little bit at the moment, how to make things not just fast and, automated. I think in the beginning, artificial intelligence, people thought, if it's automated, that's intelligence. But now we're thinking it has to be creative as well. So maybe a new move we've never seen before in chess, that would be artificial intelligence.
When a website recommends specific items to you, it has used machine learning to analyze your buying history. That buying history, combined with millions of others, is currently creating the future of retail.
So that would be really simple. That's more like the automation. It's like they leave a cookie on your computer, they remember what you looked at before, and then maybe the once you click that, you get again or something, that kind of thing. It's not very AI. AI would be if they give you an advert which is somehow similar to the previous one, but not the same. So maybe you clicked on CDs, and now you're getting a CD player. That might be AI. Or something like you click on Mexican recipe and then you get a Mexican restaurant or something. That might be, that might be where the AI comes in. And actually, this idea of what's similar is quite difficult for AI still. We have to learn that over a long time. Why is a Mexican restaurant similar to a Mexican recipe? I don't know. It's quite advanced actually for a computer to figure that out. Because maybe you don't want an advert for a tin of red beans, right?
With all that social data freely available, what could an AI mine for other uses?
I was at a talk a few years ago where someone from, I think it was the British police or some similar institution, talked about how easy it was to track down certain VIPs, in this case, member of the royal family, for example, from Twitter. Because they appeared at some festival, some public appearance, and as naturally happens on things like Twitter, people would take photos or tweet, so-and-so just went past, we just saw so-and-so, and it was frightening how quickly they could determine not just that so-and-so was at this event, but within 10 metres of their real location. So if you wanted to be frightened, you could say, gee, a terrorist could have done exactly that same thing, or someone who wanted to kill or harm this particular person, that sort of thing. So it's certainly technically possible to take a lot of information that is perhaps freely available on social media to people's own detriment, whether they realise that or not. It's certainly possible.
Another danger perceived by some is the application of AI to robotics, the natural progression of AI into the real world.
So there are lots of AI systems we call bots, bots, chat bots, search bots. And they're not really bots in my sense of what a robot is. A robot has to be a machine that works in the world. Now, inside the machine, you've got batteries, you've got motors, you've got computers, and very likely you've got AI in there. So the software inside a robot is the AI. So you could think of a robot as AI plus legs, wheels, arms, propellers, or whatever. It's got to be a machine.
Many of the things that we take for granted, I mean, if you think about it, children, how long does it take for them to learn things? It's really not that quick, right? And it's the same thing for the computer. It's really not that easy. It takes years to learn things. So deep learning accelerates some of this. And learning a difference between an apple and a pear, a computer takes a while to learn this kind of thing. So the robot is just an extension of this, where you want to pick up the red cans and you don't want to pick up the blue cans. You have to learn first what's red and what's blue. computer doesn't know that in the beginning. So it takes a while. And so deep learning is one of the things that can really help because it accelerates some of these things. It can process more data more quickly.
I think what always strikes me is the public perception of robots is so different to my perception of robots. And I've been working it a long time, I'm passionate about robots. I'm probably kind of rather skeptical about their current state of ability and the rate at which that will progress. So people are always surprised when I tell them that a robot can't sort of look at a scene and say, well, that's a human being and that's a bottle, or a robot can't pick up the bottle. You know, these are things that we take for granted. A child can do this. At the moment, robots still can't. And that boggles people because their whole perception of robots comes from what they see in the media, from Hollywood. And yeah, that's so far from what we're able to do now. Hope one day we'll get there, but it's an aspirational thing. You know, we want to be able to build robots like they have in Hollywood, but they're also a curse because everyone compares our robots with those, and yeah, we don't measure up.
Yeah, so the Hollywood version of robots is kind of interesting. So I used to think that it was a bit silly, the Hollywood version of robots, where there were literally people dressed up in a suit that would walk around. And then a whole lot of researchers around the world started to develop humanoid robots, right? So robots that look like people. And people would question why do that? Because, you know, it's very difficult, right? But there's a very good reason to do it, which is that we've built our whole world for us, for humans. So door handles are a certain height, kitchen bench tops are a certain height. The world has been constructed for a humanoid. So therefore, if you make a humanoid, almost by definition, it will be able to do a lot more than a robot of a different size or a different shape, right? So the classic example is a lift. You know, if your robot goes into a lift and it hasn't got a finger and it can't press the button, it's not going to be able to use the lift, right? I mean, that's a simple thing. Opening doors is the same thing. So the Hollywood version of humanoid robots, they had that version because they wanted people dressed up in a suit because they couldn't make a real robot, but it turns out it's actually a very sensible thing to do.
So I guess the most promising initial forays into robots that cook and fold laundry, for example, are in sort of contrived environments. So rather than having a robot in your home that uses the stove the same way as you do, it would have a specialist stove top, it would have a special set of cooking pans and equipment, and the environment is set up so that the robot is most able to do its job. The next stage after that will hopefully be robots that are a bit more capable, that have good manipulation, good vision skills, that can actually move into the home and you can trust to hold a few liters of boiling hot water near you as you get ready for dinner. Obviously that's a little way off, but it's definitely not impossible.
One obvious benefit of AI is that it can take the drudgery out of some human tasks. Industrial robots have traditionally been on the production line working tirelessly, but after being kept separate from humans, now they are coming out of their cages. And important questions arise. For instance, can AI-driven machines collaborate meaningfully with human beings?
The other area I think we'll see more and more of, and we're already beginning to see, is things like robots that cooperate and work with humans. So there's a lot of robotics previously worked in things like factories or other controlled environments where there might be humans, but very much the robots are the prime thing and the humans have to get the hell out of the way, to be perfectly blunt. What we're seeing more and more of is the Roomba style thing, which are robots in the vacuum cleaner case, pretty trivial, but nonetheless they've got to work in a space where there's not just humans, but dogs, furniture, doors, you name it. We're going to see more and more of these sort of humanoid type robots or telepresent type robots which are deliberately mimicking humans in various different ways. So I think we'll see more and more of that humanoid robot than the more specific functional robots like the Roombas or other such devices.
It's quite a a complex business robotics. So what we've had is people, small research communities, digging down into particular problems. So there's the navigation folk, and they're trying to work out about how do you get from point A to point B? How do you do it if you've got a map? How do you do it if you don't have a map? We've got other groups of people who are figuring out how you pick things up. Other group of people figuring out how do you understand a picture? How do you understand spoken commands? So all these different groups looking at very narrow aspects of robotics. Go to a robotics conference and that's what you'll find. There's a room full of people discussing each one of these things. Slowly we're starting to integrate that together. But so far we haven't really built anything that is as competent as a human being. We had people who worked on feet and legs. Now you see quite good humanoid robot machines. So a machine with arms and legs can walk over all sorts of quite complicated terrain, but they don't have a vision system like we have it. That's probably the next step of integration. And the other area of integration that's lacking is the ability to pick things up. So it's hands, fingers and arms, the ability to grasp. And not just grasp something, but to manipulate it in our hands. So I could pick up a knife, manipulate it in my fingers and then hand it to you, handle first. We're a long way from doing that with robots at the moment.
On the other hand, so to speak, advances in mobility by robotics companies have seen exceptional demonstrations of both agility and speed.
In the past, roboticists, I think, often felt limited in that even if they developed really smart robot artificial intelligence, the walking robots, the driving robots were not very capable. But we've seen recently with companies like Boston Dynamics that these walking robots are now quite incredibly capable. So now the pressure is back on the people who are designing the algorithms and the artificial intelligence, because the robot physically can do everything that a human can, and often quite a bit more. I know that I can't do a backflip very well, but the Boston Dynamics robot can.
If you look at their most recent one, the Spot or Spot Mini, a yellow robot with four legs, it's got quite sophisticated 3D sensors on the front, the back, and each of its sides. So it knows what's next to it, because it is able to walk not just forwards and backwards, but can also do a sort of crab-like gait sideways. So yeah, it's got very good spatial awareness. It knows what's all around it, and it can sense the sort of terrain and work out where it should be placing its feet.
Could robots with these levels of agility be stationed in nuclear power plants? In an emergency, could they autonomously spring into action in biohazardous conditions?
It probably would be good to do that, but you bump up into the problem of robotic capability at the moment. So a robot that can move through an environment that is perhaps physically disrupted. So perhaps there's rubble on the floor now because the ceiling came down. It's probably beyond what a wheeled robot could do. So you probably want a robot with legs, 2 legs, 4 legs, 6 legs that can go over that. It's also got hands, the ability to grasp a valve and turn it. We can demonstrate this sort of stuff in the laboratory. We can demonstrate it in competition. So there was a pretty well publicised robot competition a couple of years ago, the DARPA Robot Challenge. And robots had to do exactly those things. They had to go through doors, ride in jeeps, walk over a rubble field, turn a valve, cut a hole in a wall. And there was a robot that won that competition. Many robots failed in that competition. It's only 2 years ago. So some of the smartest, most competent roboticists in the world knocked themselves out to win this challenge, and the results were kind of ordinary. 5 years' time, we might be able to do that.
Another area where AI and robotics have already made a difference is in the field of medicine and surgery.
So the thing I'm working on at the moment is a lot of medical data, because I like that, and we're working on uncertainty. That's, I think, is a really interesting area of artificial intelligence, which we haven't quite cracked yet. So, for example, you get some data and there's something missing, some missing data, or maybe the data is just somebody lied, the data is wrong. So the data looks like it's there, but actually it's not right. So, or maybe sometimes the experts just can't agree what it means. One doctor says, yeah, it's this, and another doctor says, no, it's that. So when we have that kind of data, which is just not clear, how can we use artificial intelligence now? You can't just learn from it in the classic way. You have to come up with a new way of dealing with it. And that's what I'm working on at the moment.
I had a colleague of mine several years ago talked about an application of what we now call machine learning that actually ended up saving lives. Because there was this application of, I think it was children with cancer in somewhere like Singapore or something like that. And they had this practice of always giving everyone with these particular symptoms the same level of the drug. What he did was purely by looking at the data. He's not a medical doctor, he's not no medical expertise whatsoever. So by simply looking at the data saying, what if we varied the dose we gave to the people depending on their age or other such characteristics? And they went from something like a 30% survival rate to an 80% one. And that's without any medical knowledge, purely looking at the data. So I think there's a lot of things in medicine like that. We have a lot of data that's being accessed in various different ways, but probably only starting to mine that data to see what can we learn from that, the same way we talked about mining for retail applications, but mining for medicine is certainly one that way.
So I would have thought when you do something like with robotics and for surgery, the first thing would be to control the arm or the surgical tools really carefully, and that needs some AI because the resistance you might get from something might suddenly change and that kind of thing. So I think the control would be the first application for AI, and that's probably very difficult. So, a millimeter might make a lot of difference there, right? I think the next thing then would be when you do that kind of thing and you take an image of where you currently are, the bone, you say, then the classification of what's going on might be another AI problem. So you look at, this is a picture of your bone, and we compare it to a database of existing bones, and yes, maybe we can tell, yes, we need that kind of implant or that kind of implant.
For example, we're doing a lot of surgical robotic work, and looking inside the body. And if you use low definition cameras, you can't see much texture on, say things like cartilage. Whereas if you use very super high definition imagery and the right sort of lighting, there's a chance you can actually pick up texture, and that can make the solving problems easier.
We can preserve fine structures. We have a three-dimensional view and a tenfold enlargement of the surgical area. We have instruments that are superior to the mobility of the human hand, and we can operate without shaking.
So definitely AI can help with that. But I would also think that's still a problem where you need still a human doctor, because too many unexpected things could happen. And because we haven't yet got that creativity and all that thing, I think a human doctor would have to be there to, in case something suddenly happens or goes wrong. Because I don't think we know enough to do just AI.
Human doctors also have ethical standards, and this may be the thorniest problem relating to AI. Can an AI system be taught the complexities of human morals, the simple difference between right and wrong?
One thing that I found personally very interesting was that at one of the big AI conferences last year, there was some research presented about how do we teach machines to reason the way that Thomas à Becket would. Now, Thomas à Becket was a famous name in philosophy from many hundreds of years ago now, but he talked about this the sort of dilemma of what to do when you don't want to mean any harm, but the only way to survive is to kill someone else. Those sort of dilemmas. But finding a way to teach robots to reason in that same way, to say, there's no good choice here, but I want to take the least bad one. How do I work out what the least bad choice is? So in that sense, those sort of laws or ethical dilemmas are coming up in all kinds of ways, and I think will increasingly come up as technology gets more and more advanced.
So imagine you're driving a car and something goes wrong, and now you have two choices. One is you're going to hit a wall and hurt yourself, or you're going to hit a pedestrian and hurt the pedestrian. Now, who's going to decide which action to take, right? Well, how's the AI going to decide this? And we were talking about this and we were saying, oh, well, if we were driving, we'd probably rather hit the wall because we don't want to hit another person. Okay, so now I'm the car manufacturer and I'm designing the AI to be this, and I'm telling you when you buy the car, and by the way, when you get in a difficult situation, the car's going to hurt you first before other people. Do you want to buy my car? I think that there's a lot of legal and ethical work that needs to happen first before we can get into anything like that.
A really interesting aspect of some of the driverless cars in the US is that it's become clear, because of the way that the driverless cars interact with other cars, that a lot of US drivers don't necessarily stick to the speed limit. So the problem with driverless cars is they might stick to the speed limit and slow everybody down because they're not doing what everybody else does, they're doing actually what the law requires. Well, is it actually appropriate for the car to say, I will stick to the law, or will I do the least dangerous thing and travel at the mean speed of everybody else, which might be actually a safer thing to do? So it's things like that that become ethical, real dilemmas about what is the right way to do it.
I think there was something in the news about one of the self-driving cars had an accident. There was a big outcry about that, and we need to stop all trials now. But come on, we've got thousands of accidents on our road all the time, right? So the AI is probably much safer than the human driver. But somehow we're thinking one mistake is already one mistake too many. So what do we want here? Zero tolerance for AI? But that's not how we work, right? So.
Yeah, things go wrong all the time. It's the amazing thing when you think about probabilities. Even if something is, we might report in a paper that we're very happy that something is 80% reliable. In the real world, out in a real application, 80% reliable is actually not good enough. Right? So you need to combine all those different things that are 80% reliable to get a 99.9% reliable before you can actually use something. Yeah, I mean, people are sort of, they are concerned that, particularly if you are dealing with an AI that's totally logical, because humans aren't totally logical. It's a difference. So we'd naturally be conflicts between something that's totally logical and something like us, which we're not quite totally logical. I mean, some people think they are, but they're not really. So I can see how there could be problems. So you would somehow have to build in a more human-like way of thinking, or at least responding into a robot to sort of prevent or reduce this conflict, because otherwise, yes, there could definitely be conflict.
As Hollywood is keenly aware, human beings have a natural fear of the unknown and the new, and it has proven to be a strong influence on human decision-making. The guarded response to AI is no different.
So things like air traffic control is one that's been looked at probably 20 years or so ago now. In fact, there was almost a point where in Sydney they almost got to the point they accepted having an AI system to replace the humans. The air traffic control is one of those things that's obviously vital. Any mistake can be fatal, obviously. There are highly trained individuals here, but they're in short supply. It's a high-stress occupation. It's one of those things that all conditions are ripe for saying, surely an automated response would be better. The problem is that getting humans to be convinced that it's better is actually very difficult. Because what if the machine doesn't understand? What if there's a mistake? What if there's a bug? What if there's a problem? So there's a lot of those sort of areas where it might be natural and seemingly, in a very abstract sense, a great thing to apply AI. But the real problem is convincing humans it's safe. And I think to some extent that same fear, even in this case someone who knew the technologies, is replicated to some extent in the general public, because all they see are robots and they hear about driverless cars and drones and various other things and say, well, is it rational to think about what a drone might do if it ran out of batteries over my backyard and dropped on one of my children? Well, yes, it is. How likely is that? I don't know, but it's certainly a fear that's there. So there's always been some sort of fear associated with AI, and to some extent that's understandable and natural. We always fear the unknown and what we don't understand. Having said that, I think there are some of the more extreme statements that probably are going over the top when we talk about the rise of the machines or the danger posed by AI as distinct from where the benefits might come.
With any new technology, there are always detractors. People with influence have a louder voice than others.
I guess to some extent, people like Elon Musk or Stephen Hawking coming out and saying, AI we need to fear. Look, they're both great people in their own right, and they know, and they certainly are respected people in their disciplines. But I think to some extent we also have to realise that neither of them are AI practitioners, and a lot of time those sort of headlines are because they're famous rather than because they've got, to be blunt, anything really informed to say about AI. But that's always been the case. There's always been a fear of AI, the rise of the machines, the Terminator kind of scenario, if you like. And that's understandable because a lot of the time, we have to remember, was it Arthur C. Clarke who said that any sufficiently advanced technology is indistinguishable from magic? And magic, by definition, is something we don't understand what's going on. So in that sense, if you are so far removed from the practice of the research or the technology of the science that you can't understand it, it's natural to be fearful about those kind of things, especially when there are, in some sense, some rational fears to be had.
A logical extension of our doubts about robotic morals is the fear of weaponizing robots, giving AI the power to kill.
There was an interesting talk at the conference last week about robots in warfare, and there's a lot of debate about this, that robots would just go out and without any conscience or human oversight, just slaughter people indiscriminately, and that would be one possible future scenario. But if you look at humans in war scenarios, they don't always behave very well. There's been a long history of terrible atrocities and crimes that occur in war because human beings are emotional, they get angry, they want revenge. And the argument was made that perhaps robots would not have those attributes, wouldn't have that emotionality, perhaps would behave better in a war scenario. I think a better thing is just to avoid wars, but it's an interesting perspective.
Any technology you can use for good or evil purposes any which way you like. One particular concern of mine and various other AI researchers is things like lethal autonomous weapons. We're seeing more and more technologies like drones become cheaper, lighter, faster, more reliable. And whilst it might be a bit annoying if you've got the paparazzi now have drones that can chase celebrities over the planet, it becomes a lot more bigger problem if you've now got drones that don't just take photos, that could launch weapons or could fire things at you or various other things. So I, like a number of other AI researchers, have some concerns about these sort of drone fleets that could become very lethal if we don't look at limiting or providing some sort of legislative or regulation framework now. So there's been recently a lot of movement about getting legal requirements through the UN or other such bodies about limiting or restricting use of autonomy to non-lethal purposes, or if you like, banning lethal autonomous weapons or killer robots.
The military is certainly interested in many aspects of robotic technology, whether it's humanoid robots or whether it's going to be more like traditional military weapon systems that are controlled by a computer. So it might be that you have helicopters that don't have pilots in them, but they've got a lot of sensors and onboard AI that can do the job. We hear that the next generation of fighter aircraft are unlikely to have humans in them because the machines are capable of incredibly high performance, maneuverability, acceleration, which causes the pilots to black out. So the human pilots are now the weak point in these military systems, so they will be removed. Tanks, cannons, all these sorts of submarines, they're all going to be robotic systems without people on board. Whether you have humanoid foot soldiers, just like you see in a Star Wars movie, all those stormtroopers, I don't know.
To interact with humans in a positive way, AI will have to understand human emotions. Working with humans means coping with infinite variety, recognizing our faces and the amazing range of differences from one to another.
Absolutely. So robots certainly have to do facial recognition to understand which human is which. That's pretty important. They will have to understand emotions, and that's actually something that's very deeply wired in us. If you're starting to look confused or angry when I'm talking to you, I'm going to modify my way of interacting with you without even sort of thinking, he's angry, I better do something different. It happens almost unconsciously. So very deeply wired in humans is the ability to read the emotional state of another. Robots will have to have that as well. But not only that, I think it's going to be very useful for robots to signal their emotional state back to the humans that they're working with. So imagine a robot and you're trying to ask it to do something. If it looked confused, you would, without thinking, explain it to it in a different way or a simpler way. And I think that's really important. So there's quite a bit of work in robotics on understanding the emotional states of humans, and also you see a number of humanoid robots now with quite elaborate faces. We've got a large number of muscles, I can't remember how many it is, might be more than 20, more than 40, that we use to signal emotional state. You're starting to see robots with the ability to signal emotional states.
I have worked in a project once like this before, and we were actually trying to build a remote lie detector. So looking at somebody's face, and we were trying to find out, is the person telling the truth or not? And the idea was that certain facial expressions might give away whether you're lying or not. Okay. Now, what we found was that actually this is really difficult. First of all, there is a technical difficulty. Have the camera, take the picture, find out, is it actually a smile, or is it maybe an angry face, or what is it? But there was a second level difficulty, which was even when we figured out, yes, the person's smiling, because people come from different cultures and different educational backgrounds, it may not mean the same thing. So in one culture, smiling might mean you're happy, and in another culture, smiling might mean you're embarrassed. And so actually that turned out to be a really difficult problem beyond the just detection of the feature. So I would say this is really difficult, because not only do you have to learn what's the feature, but the interpretation later is not obvious.
So yeah, there's a lot of work going on in that area. Of course, some people just have weird ways they make their expressions that even confuse humans, right? So those people will probably still confuse robots.
Will we have AI-driven robots in every home? The motor car and the television were both once considered luxuries few could afford. Mass production will be the key.
I don't know. I'm not very good at making predictions. We certainly don't have it now. They might appear in the next 5 to 10 years. The issue is what the price point will be, and I think that's the real decider. These machines are very, very complicated. They're more complicated than a motor car, and they're going to be expensive initially, and I'm not sure who would be able to afford to buy them. You really need to have mass production of these sorts of complex machines in order to drive the price down. So while it might be technically feasible 5 to 10, whether everyone's going to have one in their home in 5 to 10, I really don't know. I suspect not.
Even as robotic researchers, we have to think about, is this thing going to be affordable, or are we just kind of wasting our time, and maybe it will have some impact in 50 years, but not now. So yes, I think now it's a big thing.
Well, I think that's what I learned over my career of studying intelligence and decision making, because there is a certain level of automation and a certain level of number crunching and repeating and that kind of thing, and it is important. But that actually is only the basis, right? And then the really good decisions come from creativity, ingenuity, novelty, that kind of thing. But let's go back a little bit to one of the reasons why I ended up doing AI. Something that always fascinated me was programming. And very early on, we had this great idea, if only we could get one computer program another computer, then we can all retire. That's great. We don't have to work anymore. So that maybe is not general AI yet, but at least it's quite high-level AI. Now, 20 years later, we still haven't got that. I can program a computer, but we haven't been able to get one computer to program another one. And turns out even that is really difficult. Writing some code, it's not easy. So I think we're far away from general intelligence, and we're even far away from some of the pre-steps of that, which would be, for example, one computer program another computer. And why is that? I think it's because we don't really understand intelligence yet that well.
AI is to some extent not what people out there are doing. A lot of it's driven by what people want. So, for example, driverless cars is something we've talked about a bit, but if there was no need for cars, no one would really care about driverless ones. If there's no need for planes, no one would care about air traffic control or other such things. So a lot of the things we see are a result of society's desires, needs, practices that we're trying to improve. It's not just about AI is out there doing stuff to society. AI is very much driven by society as well, and it often gets overlooked in some of these debates about the fear of having a hell kind of situation, or will the machines take over, and saying, well, that's really us, so it's not them and us, there's only us in some sense. I don't think it's perhaps too exaggerating to say there's no area where IT currently is, which is most of them, that could not be improved by having intelligent application of that same technology. So in that sense, there's no real limitations to where AI might take us.
I mean, one of the more interesting things about AI is this idea about explainability. In Europe, this is a little bit more advanced now than in Australia. So this is this idea that when companies use AI to make decisions, they have to still be able to explain to the customers how the decision was reached. And that's quite tricky when you get like deep learning and this gets really complicated. So I think as long as we do things like this, it has to be explainable. Then at least people can, do you want to use this computer when when this and this happens? Or, at least gives you a fair choice.
So it's really a matter of retaining explicit human control. And to be really cynical, if you're silly enough to give the machine absolute control, maybe you have to deal with those consequences sometime.
So just how smart do we or should we make them? Researchers talk about an artificial general intelligence, a computer program that's not designed for a specific task or function, but a generalist intelligence able to function like a human, to have consciousness, self-awareness, emotional sentience, and finally sapience, the capacity to acquire wisdom. Some believe it might be possible, others are not so sure. Some say as long as they can just mimic human behavior and function, what's the difference?
So I think one pertinent observation is by Alan Turing, probably the father of AI in many ways, when he talked about the need to not ask questions like, can machines think? Which is almost a question he dismissed and saying, well, of course they can't think the way humans do. The interesting question is, whatever they do, can they be made to imitate humans? So, for example, the famous Turing test, which is about whether a human can tell the difference between a machine and a human simply from the conversation itself. Then that is a way of saying, well, whatever the machine does, if you can imitate a human sufficiently that another human can't tell the difference, then does it matter whether they think like humans or not? It's the imitation of what they can do is what's important. So in the same way about could machines be self-aware, I think you could argue the same thing. Well, what is it about humans that would display, let's call it self-aware behaviour, whatever that means? Well, I would think it's quite possible to have a machine do that same self-aware behaviour or imitate, perfectly or otherwise, a human's own self-awareness, whatever that is, without necessarily saying, is this machine aware of what it's doing? Well, it's a bit like saying, can it think? Imposing these human terms where they're not necessarily appropriate. So I think as far as humans are self-aware, there's no reason to believe machines couldn't be similarly self-aware.
Yeah, I would have said no, that we wouldn't have this general artificial intelligence a few years ago, but now I'm kind of turning toward thinking that we probably will. And there's classic examples in vision where, as engineers, we used to think about vision and break it down into all the steps, acquiring the image and then maybe doing some filtering to make it look better, and then extracting lines and edges and then tracking things, and then there's this kind of sequence of events to try and create a vision system. But now with AI, researchers are showing you can just take the pictures and you can just take the output you want, and the AI kind of figures out all the stuff in the middle by itself. You don't explicitly work out what all the steps are. The artificial intelligence just somehow figures that out, and it's not programmed. So we're kind of showing that we take the sequence of things, AI just ignores that and works it out for itself. So I now think that yes, maybe we will get a general kind of AI.
So definitely we're far away from computers having anything like this. I'm not sure we need to have that. So maybe we could just design the systems without it. So I think the danger or the question people sometimes have is, what if computers develop it by themselves? I personally don't quite see that because, computers are tools and tools do as they're told. So I don't think if we designed it in the right way, this would ever happen. Now, another question might be, do we want it to happen? But that's probably beyond my sort of philosophical capacities.
So it would seem the defining difference between humans and AI is not simply speed and consistency of action. Could it be a matter of creativity? Can human creativity be mimicked or even taught, blurring the lines still further?
You took a little bit of time to understand, but we basically had to find time to understand his movements. Then, when we found the way, everything was pretty easy, and the flexibility of the arms of Yumi is absolutely unthinkable, not even incredible, unthinkable for a machine. It is absolutely fantastic. It goes far beyond the simple Taktstock, as they say in German. It is something much more evident, it is something more artistic, and the flexibility of the machine is basic for this. Absolutely fantastic.